How are you guys? Welcome back to my channel. Today we're still under the properties of fluid mechanics. We are dealing with uh, calculating viscosity force. Viscosity force needed to overcome viscosity force. We're still under the properties of hydraulic fluid. Right, the question is it as follows. We're given a 3.1 a 120 millimeter diameter piston. You see, this is the what? It's a piston which is 60 millimeter in length. This is a length. Slide in a 120.5 diameter cylinder. It's the diameter of the cylinder. That means we're dealing with piston and cylinder. This is a piston and cylinder problem. At an average of 5 meters per second, which is the velocity, that one. Then the piston and the cylinder is lubricated with an oil which has an absolute coefficient of viscosity of 0.5 poise. As you can see that that one, what it is, we're also given coefficient of viscosity there. Then says determine the following 3.3.1, the force needed to overcome the viscous force. Force 3.3.2, this says the power loss due to the viscosity of the oil. 1.3.3, the kinematics viscosity of the oil if its relative density is 0.82. Remember, alternative name for relative density is what? I hope you know that. Is the heat has its name. You remember there is a specific gravity. Do you remember the specific gravity? We are given this. Other name is given. We know this is a specific gravity. Its alternative name is specific gravity. I hope that you know. Now let us deplete a bit what is happening here. Right. Okay. Let me deplete a bit here. I can draw. Okay, we have a cylinder. This is a cylinder. Then there's a piston inside there. We have a piston. Right. This piston must have a length. Its length. This cylinder must have its diameter, which must have its diameter. Also, this one must have its diameter. The piston must have its diameter. Right, this space here between the cylinder and the piston is clearance. Right, it is clearance. I hope we are fine there. Now a 120 diameter piston, we have a diameter here. We're given the diameter, this diameter of this piston. They said it's 120 millimeter. Small d, diameter of the piston, which is 60 millimeter in length. Its length, this length of the piston here, this length is 60 millimeter. This length here was of the piston, not of the cylinder. Right, the diameter of the cylinder slides in. This must be a diameter which is 120 2.5 millimeter. The diameter of the cylinder, this one, right? As you can see, right now we're supposed to calculate our question. We're supposed to answer the question right now. You want the force 3.3.1. What do they require there? It's a force. We need a force right now. A force. Let me adjust a bit here. So about that. Let me adjust like this. Good, sorry. Good. Yes. Yeah, now it's fine. It is clear now, guys, right? It is clear. Just want to adjust a bit. I hope everything is clear. So for that quality, now everything's fine. I can see. Okay, we have this. Now we answer 3.3.1 says the force needed to overcome viscosity. We know that force must be given by coefficient of friction multiplied by area multiplied by velocity over clearance. Right. It's how we calculate what the force, right? And then now we have this, we are given it here, it is right 0.25. I've given it. We have this coefficient of viscosity. We have also acceleration, which is 5. We don't have area, we don't have clearance. So what about, let us calculate an area. Area is pi dl quad. Remember, now we're dealing with what? With the piston and cylinder. Piston and cylinder. Do not forget. Here, when we are dealing with the piston and cylinder, the length is supposed to be the length of what? Of the piston. Not of the cylinder, no, of the piston. And the diameter also must be a diameter of what? Of the piston also. When we are dealing with the cylinder and the piston, the length is supposed to be, when you're calculating the area, this length must be of the piston, the diameter must be of the piston. But when we're dealing with a shaft, if it's a shaft, this length won't be the length of the shaft. If it's a shaft, if we're dealing with the area, we're given what? If we were dealing with the shaft, right? With the shaft. If we're dealing with the shaft, just know that if we're dealing with the shaft, just know that it will be pi diameter of what is of the shaft, right? The length won't be the length of the shaft, it will be a length of what? Of the bearing or contact area, right? That's the difference between the two. This will be of the bearing, won't be the diameter of the shaft, also the length of the shaft. When you're dealing with what? With the shaft. If it's a shaft, now we're given a piston. You understand? We're given a piston and a cylinder, so will be the length of the piston, the diameter of the piston. I hope, guys, you understood what I've said right now. Okay, now since we know supposed to be the diameter of the piston and the length of the piston, so we know that pi, we want the diameter of this. We know we're given, which is the set of the piston. It's here. This is of the piston is what? Is 120 millimeter. When you divide by 1000, will give you 0.12, right? When you divide this 120 by 1000, right? Divide that by 1000. Then the length is 6. You divide 60 by 1000, it will be 0.06. Right. Now the area will be 0, if you punch your calculator, you're supposed to get 0.2262 meters squared. Right. Hope you understand that. Now we have calculated the area. We have the area. We don't have what? Clearance. Let us calculate the clearance. The clearance is diameter of the what? Cylinder. Subtract diameter of the what? Piston. We divide this by what? By 2. Divide this by 2. That is our clearance. Diameter of the piston 0,1205 minus 0,12 divided by 2. We should get that your clearance will be 0,00025 meter. Zero comma 0,00025 meter. We have the clearance, we have velocity, we have area, we have viscosity. Now we can calculate the force. Now the force, we just substitute now. Our force, we have the viscous is here, which is 0,25. Then we multiply by the area. Here it's our area, 0,02262 multiply by velocity, which is velocity is here, which is 5. It's 5. That's our velocity. Divide by the clearance. Here is clearance is 0,00025. Then we're supposed to get F. Supposed to get F as 113,1 Newton. This is the force. 113,1 Newton. That is our force that is required. We have calculated the force. We are done with question this. Now we're left with 1.3.2. Let us attempt this, the one with the power loss to the viscosity of the oil. The one, the power loss. Power we know is given by power loss. This power loss must be given. Power we know the formula to calculate power is force multiplied by the velocity. Force multiplied by velocity. We have the force. We've calculated it there. 113,1 multiplied by 5, which is our velocity is 5. We have it here. Now, supposed to get this is 565.5 watts. Right, that is our power, 565.5 watts. This is the power. Now we are left with 3.3.3. Says determine the kinematic. They want what? The kinematic viscosity. Note kinematic viscosity of the oil if its relative density. They've given us the relative density. If relative density is 0,82, its relative density. Yeah. If it's relative density, we know that the relative density is same as what? As specific gravity. Relative density and specific gravity is one and the same thing. Now we want to calculate what? Kinetic viscosity. Now we know that you'll know that the density of the oil must be equal to must multiply by the relative density, right? Relative density, P relative relative density is P relative multiplied by the P density of water. Density of water. We know that. You remember the specific gravity. If you remember the specific gravity is what? Is density of what? Of the substance over the density of what? Of water. Always. Density of the substance, which our substance there is what? Will be oil. Right. Then you multiply that side, you get the density of the oil. Now the density of the oil will be, we know this relative we have here will be 0.82 multiplied by 1000. We have that is 82 kg cubic, kg per cubic. This is must be cubic, is made must be in cubic. This is 3 there in cubic. This is the density of what? Of the oil. We have the density 82. Now we want what? Kinematic, the kinematic viscosity. Then the kinematic viscosity is given by this symbol. And then its formula is right will be the coefficient of viscosity or dynamic viscosity divided by the density of the substance. This density of the substance, you know, we're dealing with the oil right here. Or we have this, or they've given us here the okay, this is the relative, this was a relative density, fine. Now we have it here, this one, coefficient of viscosity, which is 0.25, right? It is 0.25 divided by the density of this substance. We know that is 820, right? 800, 200, 8,200, right? Then supposed to get that this is the same as, will be same as 3,0488, 0.488 times 10 to the minus 4. This is 88 times 10 to the minus 4. This is measured in meters per squared per second. That's what I know, right? It's measured in meters squared per second. This is that is what was the kinematic. Now we are done with this question. So guys, do not forget to subscribe to my channel, and then like and comment, and also do not forget you can share this to your fellow classmates and help me to grow this channel. See you on the next incoming session. Stay tuned, as I'll be posting some new videos as well. I'll be posting some new videos. Just stay tuned. Right now, on the next coming session, I want us to deal with something like this. As okay, I will check, but there's something like this. You must know. They can take a slope, an inclination here, right? They can take an inclination, they can make an inclination like this. These people do not be tricked. And then they can take this block, mental block here, maybe it's a square mental block, you see. Then here is flow, there it's oil. The layer of oil, here there is oil. You understand? They can take this, maybe this is a block that it's accelerating this side, its velocity. can extend. Let's say example for 3 meters per second. Then this, maybe it's an oil. Then they tell us this oil has 0.8, example 0.85 pass, right? Then they give you the angle here, maybe the angle maybe 30 degrees. Then they say calculate the force. They want this, the force required to resist the viscosity force. Maybe they want this force like this. Okay, they can want the force. Also, they can say they want you to calculate. They can play with this thing. They cannot. Maybe we don't have a velocity. They want you to calculate the velocity. You're supposed to get what the force, make the force, and then the force. If you're in the incline, you know we'll have something like this. You know, weight will be equal to mg sine cos theta. You remember this. Then this will be a parallel one, force due to gravity, which is mg sine theta. Do not forget these things. Also, they will apply here. We'll delete in the next coming session, not now. You stay tuned. I will attack such questions there. Right. Thank you, guys.